Good morning, boys. So in this video we are going to learn about sound and how it propagates. Okay, so sound and propagation of sound. Now what is sound? All of us know that sound, it is a form of energy, yes, which produces the sensation of hearing in our ears. Okay, so sound is a type of energy which produces the sensation of hearing in our ears. Now, how is sound produced? As I'm talking, yes, all of us know when we talk, we produce sound. Yes, others can hear us when we talk, right? So, sound is produced due to the vibration of objects. Yes, sound is produced only when an object vibrates. Okay. Now, I'm talking to you, okay, and you can hear me. If it is in a classroom situation, yes, then it is because my vocal cords, they vibrate to produce the particular sound, and that sound reaches your ear, okay, and with which you can hear me. Okay. Then we have got, what is vibration? See, sound is produced due to vibration of objects, no doubt. This vibration is a periodic back and forth motion of particles of an elastic body or medium about a central position. Yes, you have already learned about the pendulum. Yes, vibration or oscillation can be explained with the help of a pendulum. Okay, so it is also named as oscillation. See, the to and fro motion of the pendulum, we call it oscillation. Okay, and when oscillation takes place in a high frequency, then it is called as vibration. Okay, for example, you have got stressed strings of a guitar vibrate to produce sound. Yes, most of you have got this experience. When you touch the guitar, the strings of the guitar, it vibrates, right? And that vibration produces the sound. Okay, when membranes of a table is struck, it vibrates to produce sound. Okay, now sound waves are longitudinal waves. I have already told you in the previous video, yes, that sound waves are longitudinal waves. Okay, now there are two types of waves, longitudinal and transverse wave. On the basis of direction of propagation, waves, they are categorized into two types, longitudinal and transverse. Okay, so sound waves are longitudinal waves, I told you earlier. Now what happens in a longitudinal wave? Longitudinal waves are those waves in which the particles of the medium, they vibrate along the direction of propagation of wave. Okay, then a transverse wave. What are these transverse waves? In this type of wave, the particle of medium, they vibrate in a direction perpendicular to the direction of propagation of the wave. Okay, for example, we have got waves produced in a stressed string. Okay, now another type of wave which do not require any medium for propagation, we call it electromagnetic waves. Okay, so this electromagnetic waves, they do not need any medium for their propagation. Okay, these waves can travel through a vacuum. For example, we have got our light waves and X-ray. Okay, these are electromagnetic waves. Okay, now how sound propagates? Yes, sound travels in the form of compression and rarefaction that is created by the to and fro motion of the vibrating body. So you can see the reasons there. Okay, so these are compressed part and the other one is relaxed part. Okay, compression and rarefactions. Okay, you can see here, if I consider this to be a wave, okay, this is the amplitude, this is the mean position, this is the amplitude. Okay, here the highest peak, it is called as the compression, okay, and the lower valley, we call it the rarefaction. Okay, here the peak is also called as the crest, yes, and the valley, it is also called as the trough. We have discussed this earlier. Okay, and the distance between this particular two troughs or the two crests, we call it the wavelength. Okay, if I consider from here to this crest, okay, this will be the wavelength. Okay, or from the beginning to the ending of one particular wave, okay, that is called one wavelength. Okay, so sound travels in the form of this longitudinal waves. Okay, so what happens exactly when we talk? The air molecules near our mouth, what do? They vibrate in their own position. Yes, they do not actually move from their position. What they do, they just send their vibration to the next part of the air molecules. Okay, so that sending of the vibration from one part of the molecules to the other, it creates the pressure region, that is the high density and low dense area, which is called as the compression and rarefaction. Okay, where the molecules are more dense, which creates the compressed part of air, okay, that is compression, and when it gets relaxed, that is rarefaction. Okay, so next we have got that compression and rarefaction can be shown with the example of the tuning fork. You have got an experiment in your book related to this compression and rarefactions, right? So vibration in tuning fork showing compression and rarefaction in the air medium. So when we talk, yes, or when any object vibrates, it creates this particular compression and rarefaction parts in the air medium. Okay, so you can see where the density of molecules are more, this is the compressed part or compression. Okay, and where the density is less, that is the rarefaction part. Okay, suppose this tuning fork is your mouth. Okay, the particles or the sound will travel in the form of this compression and rarefaction. Okay, and will reach your ear. Suppose your ear is in the right hand corner of this tuning fork. Okay, let us not consider this as a tuning fork. Consider this as your mouth, as your friend or my mouth in the classroom, suppose. Okay, I am talking here, your friend is talking. Okay, so what happens? The wave travels in the form of this compression and rarefactions, and ultimately it will reach your ear. Okay, so this is the simplest example of propagation of sound waves. Okay, next we have got the sound waves need a medium to travel. Okay, so this experiment is there in your book. Sound, it needs a medium to travel. Just now we have talked that sound travels in the air medium. Air is required for the propagation of sound, isn't it? Okay, now this can be proved, okay, with the help of this particular experiment. Okay, so let us take this bell jar. Okay, we have got an electric bell inside. Okay, this is the bell jar, here is the cork, the switch, mains, and the below there we have got a vacuum pump. Okay, so what happens? First of all, you put this electric bell, just switch it on. What will happen? You will be able to hear the sound. Okay, after few minutes, what you do is you remove all the air with the help of the vacuum pump there. Okay, go on removing the air with the help of the vacuum pump. So what will happen? As you go on removing the air from inside, what will happen? The sound of the electric bell will go on becoming lower and lower. And as soon as the whole air inside the bell jar is out, okay, is removed, and there is vacuum, okay, no air left out in that particular bell jar, what will happen? You will not be able to hear the electric bell even if you switch it on. So This experiment tells us that sound needs a medium for its propagation. Okay, so sound travels in a medium. Sound cannot travel in vacuum. Okay. So this is the experiment on propagation of sound, where sound needs a medium to travel. That's all in this video. Thank you all.